So for the benefit of the recording, what we're going to do is look at file interactions. This will be the final set of notes that I'm going to record of me doing a demonstration in such a way. Past here will be a bit more support. This is prior to next week when you will formally have the new assignment. Again, do start thinking about families of parts. Do really start thinking about that, because you do need to come up with some type of progression that you're going to make, or some type of system that you're going to make. Right, so I'm going to go onto Blackboard, and under MP3604 on assignments, not assignments. Wow, I nearly opened up the wrong thing then. That was awkward. So let me just close that. That's a bit better. Right. So under application programming notes, and we have interactions with external references. All the notes you'll find here. So what I'm going to do is just download them all. Supporting models. Right. So for those of you who are confident, fire away, do whatever. For those of you who aren't, I'm going to try and go as steady as possible on this, because it is dead straightforward, but if you've never done it before, it can be a bit like, what's going on? So what I've done is just put in a new fresh folder. Now it's because the supporting pack that is on interactions for tutorial 5 is a zip file that has these 5 items in them. Oh, excuse me. Yeah, these 5 items in them. So I'm going to select all 5, left click, drag and drop into a new folder, and close that, and minimize that, and then I'm going to go back to my SolidWorks. So all I've done is just unzip it. Now what I really want to do is just take you through the addressing, the processing, how we do this, and how it particularly works. Now, for anybody's information, when I was doing my PhD, I was looking at piston interaction on the cylinder walls, and I was looking at thermal barrier coatings on crowns of pistons, just for a particular period of my work. And I used this to generate automatic coatings on the top of pistons. And it was a dead easy way of doing it, but I was doing it through calculation, looking at what they call a nanocomposite layering. So you end up with a nanocomposite material, and you layer it down, and it looks on an atomic level like carbon fiber laid up, but your production of it is slightly different. So what I'll do is go into Edit, and under my downloads on my new folder, I've got Excel Beam. And again, this is just because I've downloaded this and unzipped it and put it into a new folder. So I'm going to click onto Excel Beam and click Open. So under these criteria now, these commands are just basic commands. These are ones that I've declared. So Excel object, I've got XLS as an object. Now these are just because what I'm going to do is I'm going to introduce SolidWorks. I'm going to assign myself a part that's already been made, and then I'm going to grab an object which is out external to my active document, bring that object in, keep that object hidden in the background while the main application, SolidWorks in this case, continues to run, and refer to this hidden object in the background for any type of data. Now this is an Excel document. Doesn't have to be Excel, it can be text files as well. Doesn't matter at all, but what is important is that you can read in from it. So when it runs in, as ever, it goes to submain, starts the actual code, then starts with the first application. I mean, I know we've done this, and sets that as the SolidWorks active application. So basically, SolidWorks is there. That is our main target, and that's what's running. Then from there, I go to set part and SolidWorks.open object, open document. Now, all this is actually doing is it's saying wherever this file path is, make it the active document. So in essence, we're pulling one in. We're pulling a document in rather than just starting one from scratch. And when we pull that document in, we then look to edit that document. Now, the one thing that's different here, and this is where some of the bigger marks will sit. If you look here, it's fixed to a path. If you've downloaded this, you'll notice that it is fixed to a path that I've already had on my, in fact, I think it's on this PC. And this is the path where my beam is. And the issue is with that, if it moves, it crashes. So if you're running on C drive, for example, this thing comes to me. I'm obviously going to readdress it. However, there is a way of making that automatic. And I'm not going to answer that for you. I want you guys to take a look at that. I want you guys to look at applying that, and that's where these bigger marks will drop out from. So if I want to find where that address is, there is a quick way. It's a very clumsy way, but I'll always take you through this process just because I want to leave that competitive edge there for everybody to take a look at. So on my I-beam here, which is going to be our target part, what I'm going to do is I'm going to right click and I'm going to go to properties. Always, a file will always tell you where it's stored. So you look here, you can actually see where my file is being stored. So that is the location, just the location. It's not the location and name, so keep that in mind. So if I copy that and then go back to my SolidWorks, we have location and name. So in other words, I just want to overwrite the location. The slash is the actual name of the part. So if I right click and paste, it goes C drive, C users, me, desktop, folder, I-beam, and open. So that is where the file sits. Now, I do want to stress this out just because I'm frightened I'm going to end up with a million assignments of people importing nails or rivets. You really wouldn't do that. This geometry is the geometry we're going to import. It is very, very basic geometry, but the only reason I have it basic is because we can focus on the bigger things. And for anybody who doesn't know, when you're referring to dimension and dimension names, is our dimension names on? They are now. If you look on dimension names, you can see there that everything in here has been actually named. So everything here has been named, and what we're going to do is use some software to refer to that, reference to it, and then use that. So I'm going to close that, come back, and then now the next thing, I'm going to bring an Excel document. So under the Excel document, I'm going to right click again, copy, and I'm going to paste onto here. Now what we've got is a 2 points, and then activate. So what it'll essentially do now is sets the part as open, sets the Excel object as the active Excel document, and then sets the Excel sheet as the active sheet. Now this is normally when we open up Excel and you input your value, then you input your value, and then it will set it. So when you open up your Excel and you can see that first sheet that you see would become that active sheet. Now all we're going to be referring to in this case is going to be simply this. 2 seconds. this is the active document. And this is me making this up, by the way, so please don't take this too seriously. So you'll notice when we bring out a structural steel I-beam at about 2 meters, it comes back at around £10.50. You go, yeah, prices are a bit cheap there. But this is what we're going to do, and what we're going to do is we're going to drop in, and we're going to drop in on this value, and then we're going to check that value from an input from the user, and if it's wrong, it's going to go to the next one, and if it's wrong, it's going to go to the next one. This is an incredibly useful way if you're some senior designer, or if you're in charge of a design team. And the thing is a lot of people who write these API codes are very particular about letting people just touch their shit. So what they do is they tend to lock them. So you lock your API code, and what you do is you have a way for just dogs bodies to add extra things. So let's say, for example, someone comes along and then says, right, we're going to introduce a fourth option in our I-beam. All somebody needs to do is come in and populate that. They don't have to mess with your code, they don't have to mess with everything, and what you end up with is basically a catalog, a digital catalog that the code itself will just generate based around your inputs that you're giving. So this is what we're going to open, and we're going to look and try and test these values here, and if we find the right value, this then will extract these dimensions and apply it to the geometry and give us a representation. Now you'll notice that the lengths in this are fixed. This is purely because if we don't, in many instances you can go to a company and say, look, it needs to be able to operate in this condition, this is what you can get. And so this is just me trying to give an equivalent of standards. So if particular bolt size, anything like that, and that's what I'm trying to really show here. So what I'll do is close that. Need to close it because I'm going to open this from SolidWorks. Right, when it runs in, this is one of the big reasons why I wanted to still go through this, even though not everybody can quite access this. So when it runs in, it sets a Boolean status to false, and it also sets column equal to 2. So what it says is, while the Excel spreadsheet at row 9, column 2. So what you've been used to over the years is actually columns and rows. So when you refer to someone, you probably say, I don't know, it's on B3 or C25, and that's you actually doing columns and rows, when actually how you're meant to be seeing it is rows and columns. So it's row 9, column 2, and that was the starting point I was just showing you on the Excel spreadsheet. So what it says is, while the Excel spreadsheet at row 9, column 2 is not equal to null or empty cell. So what it's saying is, do it whilst it's not equal to an empty cell, and also the Boolean status of fit is equal to false. Then what it will do is it will take the value that's been calculated from here, and it captures it, but it runs into the cell that we stopped at, and it says whatever's in that cell, make max BM equal to it. And then it says if max BM is greater than or equal to M, then make it true. Or if it's not, just go to column is equal to column plus 1. So then all it does is it sets column to 3. Column then moves along the actual incrementing of the Excel spreadsheet, and then it checks again. So it now overrides the original max BM, and it now makes it equal to whatever is in row 9, column 3. Checks it. However, this time, if it makes it equal to M, what it does is it makes the Boolean status equal to true, and it also records the column. Now this is purely because, I don't know who noticed this or was paying attention to this, but when we were doing for loops and while loops, I was telling you about how it always tries to increment. So what I mean is it runs in, and then before it goes back to check the test again, it will go to column is equal to column plus 1. So what you essentially do is you capture column before it gets incremented. So then this becomes a true recording. So we stopped at 3, but then an extra one will be added, so column would finish up at 4. However, let me just open up the Excel spreadsheet because it might be easier just to show you. However, if we run this back in and we get to here, so what we know is if it's not equal to, then it will just move along to the next one. And that's what column is equal to column plus 1 actually does. If it then continues and still can't find an equal, it'll go column is equal to column plus 1. However, if it still can't find one, it goes to an empty cell. Now, if you remember, if it finds the right one, it makes fit equal true, so that stops the while loop, because fit here becomes, as I say, illegal, so it stops it. If it's not equal to an empty cell, keep going, but then if it hits an empty cell, automatically stop, so that stops it. So what you've got is you've got a way of testing to see if the criteria is met or not. And that the reason I'm going through this is this explains why this moves like it does into the next phase of this. Let me just put that over there, actually, put you over there. Right, so what it then does is it runs in and checks to see if fit's equal to true. I'm just gonna tab this along to give it a better position, like that. Oh, look at that, that's not right. Put that there, like that. That was incorrect. I've just noticed that. So what it then does is it checks to see if fit's equal to true. If fit isn't true, all it will do is it will go to the else and say there is no standard that's strong enough to meet the situation. And I've got costings there. Oh, I've spotted a few errors here, so that's not good stuff. So I'm going to move that over here. The reason I'm doing that is it's all part of if it's true. Because if it's not true, it's just going to drop out and say, look, we can't make you anything. So why would you give it costings any otherwise? What we got is it goes to else, and then if there's nothing else, it then just sends this. However, if it is true and it can run in, it then runs to part parameter, and what it actually does is the way that this has been done is I've simply recorded myself editing dimensions. Now, if you've never done it, don't get me wrong, I will show you how to do this, but I want to just take you through this running first. So what it then does is it sets the system value to row 5, column, I think it was 2, for example, if that's where we finished. And then for the next section of the breath, row 6, column 2, row 7, column 2, and row 8, column 2. So it actually extracts the right ones. And then obviously length in this case is set by L, which is what we'd originally put in for the length that was actually required. And then it will just simply move to a force rebuild and then set the asymmetric view, zoom it to fit, and then report some costings. So I'll stop that. And it brings back across, and what I'm going to do is just run it. So if I run it, the other thing that I didn't notice, you'll notice at the bottom, if you are going to open Excel in this case, you must always make sure that you close it. What you'll end up doing is spamming your PC to death, and it will wind the crap out of you. So when you come to Excel objects and application.alerts, what this actually does is, you know, when you go to close Excel and it says, are you sure that you want to close it? What that does is it disables that feature. So it just switches it off. And then when you go Excel object.application.quit, it just closes Excel, because in a moment when I run this, Excel will be running, but you will not be able to see it. So input for newtons, I'll go 2,500. And length, I'll go 5 meters. Yeah, don't judge me on these costings. It was just me making up values. 52.50. Yeah, very cheap. But anyway, so what it's now done is it's edited the dimensions based on what I was after, and then if I come to my, you'll see there what it's actually done, and that's edited it. Now, the only reason this works as well as it does is it's because it's really been designed around the idea of it being flexible in such a way. So what I meant before when I was saying if for your assignment you choose to do something which is heavily complicated, it is dependent on how well it's been done. If the geometry has not been done very well, what you'll end up with is when you change the dimension, everything goes bright red and everything just falls on its arse and shits itself. And in that case, you're no better off than when you first started. It's incredibly frustrating. So as simple as it might come across, it's often not. To give you an idea, I did have a student, a formula student who imported the cart one year and just did loads of variant designs to it, or did something from the geometry that give variant designs to it. For this assignment, I'm going to let you pick. There is going to be no complication factor to it. You are going to be tying yourself up into knots all by yourself. In this, you are expected to put enough complication into it. So if you come in and go, right, I'm going to do I'm going to do an iPhone maker. You go, family of parts. If you're going to do that, I want a variation of right from very first iPhone through to now. With that, I want detailed camera, detailed fixtures, detailed charging ports. In the port, I'll be looking for the pins to actually enable it to it. Because this is about specifics and not half-cocked, roughly this size, this will be all about dimensions. The dimensions need to be right. So in that aspect, you're able to do something like that, but I am pushing for the highest level of detail. If you can't provide the highest level of detail for it, and you have one dimension, then don't do it. You're going to tie yourself up in knots, and you're going to just wish that you didn't even start this as an assignment. So I often refer to engine parts just because it's an engine part. They are brutal through and through. So much going on, so it makes life easier. If I just refer this with the assignment, but if you do come along and you do have, you can get around, let's say, 60-70% of the overall dimensions that are needed, but there's bits of them that you can't get. I'll accept you filling in the blanks as far as that goes. But if you're doing one dimension and then in that dimension you're just making the rest of it up, it's not good enough. It needs to be more specific than that. So it's just something to keep in mind. Right. So, is there any questions about this? About using external referencing? Again, for those of you who are using Horizon, I do apologise. You're probably not going to get the access to Excel. Again, if you don't have it, I can't assess you on it, so it won't be there. But I did want you to see it. That's the important thing. Has everybody done dimension naming before? I'll presume the gospel silence as yes, which is great. So then I have a challenge for you. You've a multiple choice now. You can either do one or two things. This is the interface. This is the beam itself. If you do have some ideas for your assignment, please do let me know. Again, must be a family of parts. Cannot be just one part. Just as a brief intro, I know this is still being put together correctly, so don't judge me too much on this. But this is going to be your assignment. Again, this will be uploaded, and to give you an idea, I will be looking for things like flowcharts and things like that. And I've tried to give you as much guidance as possible as to. I've even tried to provide some examples. Now, these examples I've given over the years just to give you ideas of what you could do in this this assignment. Okay. Then, if there is no questions, then I do have, as I said, I do have a good example. Not that one. So this is the spreadsheet. This is the interactions. There is one last bit of a challenge for you. And this is the bolt diameter and lengthening. And within that bolt diameter and lengthening, what this is looking for is not just a one-dimensional system anymore. So this needs to be able to move from diameter to get the correct diameter from the user, and then try and find the closest value that it can. So let's say they go 8 millimeters, so 8 millimeter diameter, and then what they need to be able to do is select the correct length. So if they went for something like, I don't know, 18 millimeters, it would need to go from 12 to 15 and then drop out at 25. What I have done, but this is not the answer by the way, but what I have done is I have provided a bolt. Now this bolt is broken. This one is heavily broken, but it's just to get you started. So, any questions? Fantastic. Okay, right. Well, what I would now recommend then is that you have a go at this. I'm not going to do much more on this now. This has just been the interfacing with it. I wasn't sure who'd done dimension naming before, but from the sounds of it, you've all done dimension naming before. If you do intend to import geometry, do keep in mind there needs to be a good level of complication around that geometry. Something like this, I've only used this just because it's a nice one to explain about what it's actually doing and how it's functioning. So under my dimension, under my drawing here, this is where you'll find all the dimension names attached, and it's the same type of thing, so do keep that in mind. Right, okay, then I'm going to stop recording